Welcome to sixth grade math. That was your homework that was due on Google Classroom. Get ready for the lesson. Hurricanes. The table shows the number of Atlantic hurricanes in different years. So there's the data in the table. Order the data from least to greatest. So we're just going to put that in order. And then which piece of data is in the middle of the list? So if we count the number of pieces of data, 1, 2, 3, 4, 5, 6, 7, there's 7. So that means that the fourth piece of data, 1, 2, 3, which is number 8, will be the middle because that'll leave 3 on either side. And then compare this number to the mean of the data. So if we add up all the data and divide it by 7, because there's 7 pieces, we'll get 57 over 7, or 8. Roughly 8, about 8. Both the mean and the median are 8. Measures of central tendency. Describe the center of the data set, mean, median, and mode. So the median is the middle number of the ordered data when there are an odd number of data. So in that last example, there was an odd number, 7, so we could count in and take the exact middle number. So if we have a data set of 3, 4, 8, 10, 12, 8 is going to be the median because there are 5 pieces of data, so 8 is the middle number. The mean of the middle two numbers when there are an even number of data. So 2, 4, 6, 8, 11, 12, that is 6 pieces of data, so there's no exact middle number. So what we're going to do is we'll take the two middle numbers, 6 and 8, because those are the two in the middle, and we'll just take their mean. So 6 plus 8 equals 14 divided by 2. So the mean of the two middle numbers is 7. And that's going to be the median. Mode. Mode is the number or numbers that occur most often. So in the data set 12, 23, 28, 28, 32, 46, 46, there are actually two modes, 28 and 46, because they both occur the most. They both occur twice, and that's the most any number occurs. And there it is, mode 28 and 46. Find the median and the mode. So monkeys, the table shows the number of monkeys at 11 different zoos. Find the median and mode of the data. So here's all of our data, and we're going to order this from least to greatest. So there it is, least to greatest. And we need to find the median. So how many pieces of data are there? There's 11, so we can count in 6. And our median should be 28. And mode, which pieces of data happens the most? Well, just scanning real quick, I see that 18 occurs twice, and I think that's the only one. Check your progress. So buildings, the list shows the number of stories in the 11 tallest buildings in Springfield. Find the median and mode of the data. So these are the number of stories in the 11 tallest buildings. You can see there's a decent spread. So we have the median, and it's going to be 30. It's the 6th in, so there's 11 pieces of data, and the median is 30. The mode, which one happens the most? And the mode looks like 40 to me because it happens twice and it's the only number that repeats. And then there's the range, the difference between the greatest and the least value of the set. So a large range indicates the data are spread out, and a small range indicates the data are close in value. So here's an example. Ella collected 125, 45, 67, 150, 32, 45, and 12 pennies each day this week for a school fundraiser. Find the range of the data. So that's how many pennies she found each day. And we're going to arrange the data from least to greatest. And there it is. And then we're going to subtract the least amount of pennies from the greatest amount. So 150 minus 12 equals 138. So the range is 138. And then we're going to write a sentence that describes how the data vary. And the range is relatively large, so the data are spread out. When you're talking about pennies in increments of 138 is pretty large with this size a data set. If you had a huge data set, that might not be a huge range. If it was starting, say, in the thousands. If it was the difference of 138 and it was like 1,000 to 1,038, that might make us view the range a little differently. And there's how that's talking. So that would be relatively small if it was in the thousands. 138 would be relatively small. Check your progress. Tests. Santos science test scores this year were 98, 83, 75, 74, 70, 82, 95, and 88. Find the range of the data. So we're going to arrange it by magnitude, least to greatest. And there is that. And we have a range of 98 to 70 or 70 to 98. So we're going to subtract the least from the greatest and we get 28. So the range of his tests are 28. And we're going to describe how it varies. And it's not very spread out, right? 28, when you're talking about 70 to 98, that's kind of close in range. Real world example. Weather, find the mean, median, mode, and range of the temperatures displayed in the graph. So the mean, we have these numbers, and we do have to guess a little bit. Not guess, but make some educated guesses. So Sunday, we're going to say that's roughly 64. Monday's easier. That's right on the line for 70. Tuesday, we'll say that's roughly 56 because it's closer to 60 than 50. Wednesday is even closer to 60 than Tuesday, so we'll bump that up to 58. Thursday's easy because it's right on 60, and then Friday again is right on 70, so we know that. And then there are 6 pieces of data. Notice that Saturday is missing, so we'll add those up and divide it by 6. So it's 378 divided by 6, and so our mean temperature is, or high temperature, is 63 degrees Fahrenheit. And then the median, if we count the data, there's 6. So that means we can't just pick a middle number. We're going to have to select the 2 middle numbers and take their mean. So 60 plus 64 divided by 2 equals 124 divided by 2. So the median is 62 degrees Fahrenheit. So it's very close to the mean. And then the mode is going to be the number that happens most, and it looks like that would be 70. So the mode is 70 degrees Fahrenheit. In the range, if we subtract the highest number, the lowest number from the highest number, is 14 degrees. Check your progress. Find the mean, median, mode, and range of the costs in the stem and leaf plot. So this one will be a little easier to pull the numbers out than the bar graph because it's very clear to us what the numbers are, right? So we go 15, 19, 20, 24, 25, 29, 32, 35, 38, 39, 49, 58, and 59. And we know that because if we look at the key on the stem and leaf plot, it says 5/8 equals 58. So we know that the stem are the 10s and the leaf are the 1s. So the mean, we're going to add all those up and divide it by 13, which is the number of pieces of data. And we'll get 442 over 13, which is $34. The median, so there are 13 pieces of data, so we can count to the 7th piece of data, and we know that that is the middle number because it's an odd number of pieces of data. So our median is $32. And then our mode is, if we look, do any numbers repeat? They do not, so we don't have a mode. And the range, if we subtract 15 from 59, is $44. Test example. The table shows the approximate size of the world's largest subtropical deserts. Which statement is supported by the data? Half of the deserts listed are larger than 220,000 square miles. So if we look, it's at least half, right? It's not exactly half because 220,000 is the second lowest out of 5. If it was the third or middle number, then that would be true. The most common desert size listed is 220,000 square miles. That's not true, that every number is listed once. The desert sizes are very spread out. So I think that's right because the lowest is 175,000 square miles and the biggest is 3.5 million square miles. And then if the total area was divided equally among these deserts, the size of each desert would be about 850,000 square miles. Not sure about that. We'd have to do the math. So let's go through, and the median is 250. There's no mode. The range is 3.325 million because we subtracted 175,000 from 3.5 million. And the mean is 1,029,000. So A refers to the median, but the correct median is 250, which is what we said, right? Half the deserts listed are larger than 220,000. That is not true. Half of them are larger than 250,000. That's the median. The most common desert size is 220,000 square miles. That refers to the mode, but there is no mode as we discussed. And then the desert sizes are very spread out, and that's correct. Refers to the range, and data are very spread out. When you're talking about something that starts at 175,000 and the highest in that range is 3.5 million, that's a big range. Now again, if we were in the hundreds of millions, would 3.5 million be that big of a range? Maybe not. But because we're starting relatively close to zero, 175,000 is a very small fraction of the entire range. And then D, if the total area was divided equally, each desert would be about 850,000 square miles. So that refers to the mean, but the correct mean is over 1 million square miles. So that is not correct either. So the answer here is C. All right, so we have a similar problem for check your progress. Hockey, the number of goals scored by each player on a high school hockey team is shown. Which statement is supported by the data in the table? If the number of goals were equally distributed among all the players, each player would have scored 3 goals. Don't know if that's true. We'll have to do the math, so we'll come back and check. And then half the players scored more than 3 goals and half scored less than 3 goals. Again, we'd have to order this data in order of magnitude from least to greatest, and then we would be able to tell if that's a true statement. We will come back to that as well. And most of the players scored 2 goals. So if we ordered this from least to greatest, we could add it up. I would say that just looking quickly, 0 seems to be the mode. Just quickly off the top of my head, but we'll see. And then the range is 13 goals. I don't think that's true. I see a 0 and a 15, which would make me think it's 15. So the median is 2. The mode is 0. The range is 15, and the mean is 3. So let's fill these in. And if the number of goals were equally distributed among all the players, each player would have scored 3 goals. This refers to the mean, which is 3 goals per player. So that one is correct. But let's just go through the other ones to see as well. Half the players scored more than 3 goals. It refers to the median, but the correct median is 2. So that is incorrect. And most of the players scored 2 goals. That refers to the mode, but the mode was 0. That's what we thought. There's, I think, 4 zeros. And then the range is 13, and that's incorrect. As I stated, the lowest number was 0, and the highest was 15, so that means the range is 15. So the correct answer is F. Additional problems. The table shows the calorie content of various vegetables. Find the median and mode of the data. So listed data set from least to greatest. There it is. It's order of magnitude, so least to greatest. And the median, so there's an even number of data, so we have to take the two middle numbers and get the mean, which is 28. So our median is 28. The mode, we need to look and see which one happens the most. So 15 happens twice and 25 happens. Additional problems, temperature. The high temperatures for Las Vegas last week were 65, 68, 72, 65, 80, 55, and 65. Find the range of the data. So we'll just simply multiply the least from the greatest. And if you can't pick those out, probably the best strategy is to go ahead and list them in order from greatest or from least to greatest so that you're not trying to guess. And you get 80 minus 55, so the range is 25 degrees. And write a sentence to describe how the data vary. The data are very close in value, and I would, very close might be a stretch. Oh, fairly close. That's better. I'm sorry, I misread that. The data are fairly close in value, and I agree with that. And here is your homework for tonight. Go to Google Classroom and enter it there, please. And thank you, and have a great night.